Well, good morning, everybody. In today's forecast video, I've got a lot of what I hope you find to be very interesting analysis to cover. We're going to do things a little bit out of order. I'm going to actually cover some long-range information first, and then I'm going to dive into this pattern once again and just put it in the broader context of spring. Now, later on today, in about, 5 hours from now when I'm recording this, we will be getting the new European model data. That'll be seasonal, it'll be a 7-month forecast. And I'm going to put that in my Monday forecast video after I've had the weekend to look it over. But the first thing I want to discuss with you today is the satellite animation from yesterday. And I just want to show you a couple of neat things on this. First of all, we can see some of the prescribed burns that were happening in parts of Kansas and Oklahoma down into Arkansas and even parts of the Delta down here. Shows up pretty well with the clear skies. You can see the smoke pretty well. But what I want to talk about, just to get us started, is the sheer size of this low pressure system. Now, when we teach new students about these, we call them extratropical cyclones. So they're outside of the tropics, and they're largely dominated by wind shear, to be honest with you. That's what creates them and what gives them their shape, this big comma shape to them. And as a result of that wind shear and the profile of that wind shear, they spread out. They're huge. And I bring that up because we've got two right now. One that is leaving the East Coast that is absolutely enormous. And then we have another one that's a bit smaller, but still huge, that's coming along the West Coast right here. And you can see up to late last night what it's been up to. Now, this guy's going to make a turn and come out here and eject in the northern plains. I'll show you that more in a few minutes. But I make a comment about what we call them. Extratropical cyclones are sometimes called mid-latitude cyclones. And I say all that because I want to do a quick comparison between these and tropical cyclones. So just to kind of understand it, if we just outline this whole thing, it goes off the page, and it comes all the way down here and right in through there. A massive hurricane, let's take a really, really big one, would probably only be about this big inside of it if you just kind of displaced it and put it there. And that's what the effect of wind shear does. Now, hurricanes can't handle wind shear, but that's why they stay as a tightly wound, nearly symmetric, rotation, large rotation of clouds. So why I bring all this up is because yesterday we had released to us from Colorado State University, and this is some of the best in the business, and I not only respect but appreciate this work, and I'm thankful that it is public. But this is work that's being carried on by Phil Klotzbeck, and what he's doing here is giving us a 2024 hurricane season activity forecast. And in my opinion, it's the best in the industry. And what we've got here is their forecast compared to average. And there's several categories like number of named storms, named storm days, how long they're out there, all the way down to major hurricanes and accumulated cyclone energy. Now, this made a pretty big splash in my community, the weather community, yesterday on Twitter when he released this, which was, again, such a fantastic thing. But I just want to show you the numbers, right? In every single category, we are well ahead of our 1991 to 2020 average numbers. And some of the big reasons, which he states and talks a lot about in this report, which you can go get, it's just tropical, or you can just Google CSU 2024 hurricane, and you'll find this very, very easily. But one of the things he discusses is there are several major factors, wind shear and temperature being two of the biggest that are influencing his forecast. And he does this statistically. So he's looking at historical evidence to make a case for why this upcoming season could be big. And that's what we're doing as well. Now, this is part of what he's basing this off of in early April. This what we would consider to be a very active, maybe even hyperactive hurricane season. And what he's basing a lot of this on is the fact that we are losing our El Nino signal. And we have very warm water in what's called the main development region here. And on top of that, all the long-range models continue to show a lot of activity coming off of the Sahel, giving us a lot of African easterly waves later in the season. Now, I mentioned a moment ago, what makes extratropical cyclones so large is the wind shear. Wind shear is also a critical factor to tropical cyclones. And the reason why we talk a lot about El Nino and La Nina with respect to the Atlantic hurricane season is because when there is a La Nina brewing over here, we tend to reduce the wind shear here. Now, hurricanes can't handle high wind shear environments. It actually just disrupts their heating and spreads it out. That's one of the things. And it also ruins the central structure of it, the eye. And therefore, hurricanes need to evolve and spin, which they do violently, inside of still environments. La Ninas tend to promote that. So you combine the fact that we're watching a La Nina develop and the very warm ocean temperatures, and those two things historically have correlated with much above average hurricane seasons. Now, very quickly, you might hear a lot about this in the next few days if you're in tune to this particular weather forecast. We cannot at this point make any sort of sound judgment outside of speculation on impacts across the United States. I mean, we can have hyperactive hurricane seasons that miss the U.S., right? They can all stay out here in the open Atlantic or go through the Caribbean or somehow not get into the Gulf. So I just want to be clear on that. All we know is that right now, statistically, things are lining up in a way that has correlated historically with an active season. Now, I loaded up my forecast video yesterday with a discussion about these ocean temperatures. And if you remember yesterday, one of the things we did is we walked through these years that had very cold ocean temperatures in this area, like 2012 by June, 2002 by June. I did another one, 1981. These were all very, very hot and dry summers in the Midwest. And I'm going to tell you, even though I'm focusing on the Midwest when I did that analysis, and again today, the implications of this hit the coast as well in the South. So again, the last one I showed you was this year. So when we think about this and go back to those years where it was just really hot and dry, I just showed 3 again. What is it about these ocean temperatures that's signaling to me the potential for a very dry year? What could signal? Let me rephrase that. And why did I tell you yesterday I'm not yet alarmed about this? So here's what I did this morning. I'm going to pick on the Corn Belt, and I'm going to look at June through August precipitation. So this goes back to 1895. I put a trend line on it since 1970, just so that you can see that even though precipitation volatility has been quite large across the Corn Belt, overall from 1970 to now, we've had an increase in precipitation throughout summer. But remember, most of that's coming via thunderstorms. The nice thing about this Climate at a Glance tool, which I linked for you a couple of weeks ago, is that you can come down here and you can change the ranking from the driest to the wettest and see what the precipitation totals were. So here's what I'm going to do. I went and grabbed the driest. I've got 2012 in there, 88, 76. You can see the years down here. And this is what I want you to remember about this. Why do the ocean temperatures get cold? Like that, remember I told you they're the symptom. It's a symptom because of this guy right here. What you end up getting as we approach summer is more frequent troughs of low pressure that sit in the Gulf of Alaska up against the west coast. So what does this do? This blocks, via cloud cover, sunlight, which will heat the ocean surface up. 2, tends to be windier, and it tends to therefore drive bigger waves, which churn up colder water from below. Whenever we have during summer a big low that sits here, more often than not, the West Coast, you tend to be cool, you tend to be wet, which can be a problem for West Coast crops. And same thing for parts of the South and East Coast. That's what we tend to get. But what tends to happen whenever we get the pattern doing this, what triggers it, is that normally north of Hawaii, there's this thing called the Pacific High. And it leaves. Sometimes it goes over toward Japan. Can you see it there? That's where the high is located. And then there's the Bermuda High, which sits here. And it normally leaves and goes toward Europe. So what's left in the middle is flow that comes around this low and bunches up into a big blocking high that gives us this omega look in the pattern. So you see, we're looking at the feedback in the ocean temperatures, which is behaving that way because of what the atmosphere is up to during that time. And you say, well, what causes the low that happens right here? It's almost always a loss of momentum. The jet stream loses its momentum. And we can correlate that back to the behavior between the trade winds and the westerlies. And if you really want to take it all the way down, that's all a part of these large circulations in the atmosphere, which are part of like the Hadley cells, which are broken up because of the Earth's rotation. And the reason why they exist is because the Earth is round and it's unevenly heated. It's hotter at the equator than at the pole. That's the whole story kind of stitched together. So now we come back to the graphic I showed you yesterday. You see, the symptom is the ocean temperatures. The cause is the movement of these 2 large high pressure systems. And if they move, then we get a big omega block that sets up in the midsection of the country. And look, there's troughs east, there's troughs west. So cooler, wetter, scorching hot, and very dry. So now you see what I'm trying to kind of stitch together for you? It's kind of more like a chicken and the egg kind of discussion here. So let's do this. How about those years? There they are. What happened June to August to the ocean temperatures? Well, we got very warm north of Hawaii, but very cold in this kind of reverse C shape here. And many of those years had a La Nina. Take note that they were also cooler in the Atlantic. Next, what did the MJO do? Well, during these years, when we had La Nina's building, the MJO tended to love to live here. You say, well, what does that mean? That means there was a lot of rising motion in this section of the ocean. One more thing. If you look at how those years that were really wet behaved, the MJO lived much closer to North America. There's a lot of suppression in the atmosphere here. And if there's rising motion here, that's typical of La Nina. In fact, you can see what it ends up doing. In fact, I'll go to the ocean temperatures next. Typical of El Nino. So what you typically get here is some warmer water, and warmer water. See that? And what that does, let's stitch this all together now, is that ends up producing a ridge of high pressure in this year. Well, let me rephrase that. It doesn't produce, it is the result of. So instead of now having the Pacific High north of Hawaii moving over to Japan, it moves to the Gulf of Alaska. So what this does is this takes some of the high pressure from the Bermuda High and pushes it here into the southeast, maybe some here over toward Europe, but the jet stream pattern does this. And the significance of that, shifting this all around, is that there's broader troughs of low pressure that are now living east of the Rocky Mountains. There's high pressure over the southeast pumping in the moisture, and that's why those tend to be the wet years for the middle part of the country. They're very hot and dry for the southeast, and they tend to, late in the season, get very hot along the west coast as this high migrates in this direction. So my point in all of this is that those really wet years tended to not have cold water here and not have cold water there, and certainly not have a strong La Nina signal to them. And that's why we come back to this and say, why are the models looking the way they are? Well, we're going to go away from El Nino toward La Nina. That's part of the confusing part of the summer pattern. But this is warm, and this is not overly cold yet. So what do we do with all of it? I'll show you this again. I've showed it to you several times. I'm just going to go use all of those years where something like this happened, something similar. And what we tended to get out of this pattern was drought that ended up settling in across the south. Some years it was here, some years it was in the mid-south, some years it was in the southeast. Like 2016 was a really bad year in the southeast. What happened to the north of that was flow that came in and gave us these ridge riding storms. But it got hot. It was a hotter summer. It was a hot and wet summer in through here, hot and dry summer there. And you can see kind of the epicenter of that heat was over the Ohio Valley, where I've noted that it was more likely due to very warm overnight lows. Not necessarily extreme high temperatures, which are possible, but it was mostly overnight lows. In fact, if you go look historically at the change in the Ohio Valley, June to August, in minimum temperatures, and just detrend this from 1970 on, and again, it's very important that I started that in 1970. Can you see there's kind of a time period there where it was down? You can see that since then, this is 50 years, 50 plus years. There's been an increase of about 2 degrees overall in the overnight low temperatures. So now I think you may understand a little bit more why this is my current summer analog forecast. And the models aren't necessarily in agreement with this. And we're going to get a new one in about 5 hours from now. That's the European model. And I'll show it to you on Monday. We'll just keep building this case. But I wanted you to see today what I'm thinking about. All right, let's get back to one other thing. This particular spring, March 1st up until almost now, what have we had? We've had a high pressure center sitting there. Now remember, what I analyzed for you is summer. But what that high pressure cell has been doing is that it's been sending the jet stream over the top. It's come down here in the southwest. And instead of having this ridge sitting here, it's been sitting a bit farther off to the north and east. You say, well, why? What does that matter? That matters. This pattern we've been in matters because this is what our temperatures have done in response. So for that whole time period, March 1 through April 4th, we spent most of March very, very warm in this area, right? And then it got cold after about the 21st. But the West Coast has not broken away and gotten any heat at all. And that's a major concern for me. We need to get accumulating heat here. But look at what it did to the precipitation pattern. Now, normally, if we'd start talking about dropping deep troughs of low pressure here, we tend to make this whole area, I can just keep scribbling here, all of this wet. Yet we have developed some drier places. And we've talked about them a lot in the last couple weeks. Why have they been dry? Because instead of having a big, Bermuda high sneaking over into the southeast, pumping in all that moisture to fill in these gaps, it's not been there. We've not had the southeastern ridging, especially over the last several weeks, that's necessary to make it storm and rain like mad all through these areas. So that's why there's still some drier spots that are showing up. Now, lately the pattern has been producing some precip, and I thought we'd just start off on the snow side of it, because in the last 72 hours, we're getting kind of the tail end view of the event that happened earlier this week in the upper Midwest, but we can now get these totals, which I think the models absolutely nailed. This was really a good forecast, hitting what the snowfall totals were in parts of the Northeast. By the way, I mentioned the last couple of videos that I wanted to have a look at the season-to-date departure to see what happened here after we accounted for all that snow. Well, now these anomalies are down here just a couple of inches off of normal. So that was how significant that was, albeit an April snowstorm. That's the significance of that. But this is your overall map for the season-to-date departure from normal. If we look at total precipitation through the last week, and this was just followed through early this morning, the rains that came through parts of the central and eastern Corn Belt were huge. We had a lot of scattered and severe storms to the south, of course. We had that large area we keep discussing that's been missed here in parts of the Western Plains, although there were some really good storms right in between. I was talking to some of my colleagues from Texas about this yesterday, and also these storms in Texas. Yeah, they were hailers, and they had some strong wind, but it brought in some much needed moisture. And you can kind of look across the northern plains back in the west as well. But the rains that came through this area were critical because of this. Back on March 1, this is what our 100 centimeter soil moisture calculation looked like from NASA. Remember, this is a percentile. So we're just comparing this to historic past. And what we can see now is that that map looks like this. So where are there still some problem areas? Well, certainly large sections of Kansas and Missouri, getting into parts of Iowa, and this section of the Mid-South. And those are also areas we're looking at that are still under drought. Now, I did get asked a great question yesterday about the southwestern monsoon, and I will be talking more and more about the southwestern monsoon once we get through spring, because what I need to wait to see on the southwestern monsoon is, because there's a lot of drought down here despite decent precipitation. The best scenario for the southwestern monsoon is to put high pressure in summer here and low pressure in summer there. So the flow comes in like this, and it just storms like mad. We're going to talk more and more about that soon, but that's one of our areas that's in larger influence of drought. Overall, the drought monitor didn't change too much from last week to this week, just small changes. And that's because the data are released on a Tuesday, don't forget. But we went from 40% covered in drought in fall now down to 18% covered in drought. Now remember, when I say covered in drought, I'm not including the abnormally dry category, which is this one. That's the first category, that light shade of yellow in there. Okay, with all of that, can we now get into where the pattern's going? And a lot of attention is going to go right back to the West Coast. We've had multiple lows sliding to the south, gathering their strength along the West Coast and sitting over, parts of the Southwest. And this is a potent system last night that came through California. And we'll show you again, we've seen lately how much snow came through out in the Sierra Nevada mountains, the rains that have come through with this. We've even had some convection, some storms popping off in this. But the reality is that today, as it moves farther, here it is, into the Southwest, we're going to really open up. So can you see it? There is the low, and there's high pressure here. So if we get that late in summer, then yeah, we drive a big southwestern monsoon. It's kind of see how that relationship works, but we're not in that season just yet. What we have is the low moving through now. We have higher pressure sitting down here in the Gulf of Mexico, and we're watching one system exit with its really cold air on the backside and a rapid warm up with incredibly windy conditions, not just here, but extending all the way up into the Canadian Prairie later today. And that is why our all hazards weather map at 5:15 this morning shows, throughout almost all of the western states, especially in the central and southwestern part of the country, straight through the Great Plains of the United States, we've got red flag warnings, high wind advisories, we've got high wind watches, high wind warnings. And then on this side, where the air is still coming out of the north early this morning, this is all freeze warning and freeze watches. So there is, this is a frost advisory. And so it's amazing to see that sharp divide on who's going to be warm and who's going to be cold. And it's really only warm spot in the country is right up the middle where the winds are coming up out of the south. All right. So because of those strong winds, today we do have a pretty large area that's under the critical fire risk. We can look out there tomorrow and see that a large area again. So this is going to be a multi-day event as this low very slowly makes its way up toward like Colorado, Wyoming, Nebraska. So to see all of that, let's get to the models finally. Let's pick this up at 6 a.m. We watch one system exit northeast. Snow showers there. Broad, widespread snow showers and convective snow at times here, tucked away in this broader trough throughout the mountains here. It's, of course, enhanced by the mountains. But where are we in time? This is early Saturday morning. Now, look how tightly spaced these isobars are. That's your indication of these very strong winds. So they're already going to be there early in the morning. So this brings in some snow right along the spine of the Rockies coming out of Montana. And you're going to watch as we go through midday Saturday into Saturday evening. You can see where the low emerges right out of Colorado. So some very heavy snow and very strong winds on the backside of this and into Nebraska and out of southeastern Wyoming. Now this is a pretty tightly wound low, and we will be watching out on Saturday evening for the risk of strong to severe storms right in through this corridor. There's going to be some decent forcing with this system to potentially produce those strong to severe storms. But this is Saturday night as we work our way overnight into early Sunday morning. That low curls up and stacks up just like the previous ones do. So it kind of sends this broader shield of precipitation out ahead of it, snow on the back side of it, and it's going to sit there and spin. I told you yesterday it's going to take a while to move out. So when does it move out? Well, we're going to use just a little different view this morning. WeatherBell didn't get a 0Z update. I told you I've been having problems with the European model. It looks like other people have as well. It's a data delivery issue. So let's talk about it. That's the low right now. As we play it forward, here it is by midday Sunday, early Sunday. Now, why is it stacking up and not moving? That's why. Big blocking high right there. But as we play this forward, that low eventually dies out somewhere over Minnesota. And this will happen by Monday, Tuesday. And then here's the next storm system that's coming out of Arizona. I'm just rocking back and forth over Monday and Tuesday into Texas. And this guy's going to set up a 3-day potential for severe weather event and also possibly give some cloud cover that might ruin eclipse viewing down here. Now, meanwhile, as that low comes through, there is one distinct difference in it. It's not connected to really cold air. See, the trough is all pinched off down here, and the jet will run north of it. So the west will warm up while this low sneaks across the south, giving us severe weather threat next Monday, Tuesday, Wednesday, maybe be into Thursday over parts of the southeast. And that low will deliver a shot of cool air here across the Great Lakes states, Ohio Valley, into the northeast as we approach next weekend. But then after that, the next low has a much different trajectory. Remember, we've been talking about this other system right in through here, maybe the 12th through the 15th. It stays pretty far to the north. And what you've got here are higher heights across a lot of the country, an open planting window that's going to happen, and some very mild conditions. So the result of all of it is, let's go look at the artificial intelligence forecast for precip, and then we'll look at the temperatures. Now with that second low, the one that's coming out very slow and cut off, we again see the models drawing moisture back into Texas. Need this badly. Very, very wet in parts of the lower Mississippi River Basin through New England. But there's a chance for bringing in more precipitation right into this corridor as well. But I'll highlight those areas that are showing up drier in the pattern. And to go next to the models, I got the dumb European model fixed on my end today. I'm so happy for that. But if we go forward through Friday into Saturday, into Sunday, there's the low, both in the GFS and the Euro, curling up at the same point, goes up to Minnesota and dies. There it is. That high north of it is kind of helping to squash it. Now at this time, it's hard to see, but the other low is coming right here over Arizona, New Mexico. When is this? This is Monday at 1 p.m. We will talk about the cloud cover from this in a moment and what it might do to influence the eclipse viewing. But here we go Monday night into Tuesday morning. The severe weather risk is going to be here. We'll then go ahead and play this out through Tuesday. Remember that low slow, so it's again there on Tuesday night. We just keep playing this again into Wednesday night. All it did was move to the lower Mississippi River Valley. So that's Monday, Tuesday, Wednesday evenings, the risk of strong to severe storms. This is what's producing such heavy, heavy rains in the Delta, lower Mississippi River Valley. And then that low curls up, goes through the Ohio Valley, stretches into the southeast by next Friday, and rolls through the East Coast. After that, this is the 13th, the next system's way up here. And that's the change we've been talking about for quite some time. Okay, how about that severe weather risk? This is Monday, That's Tuesday and Wednesday. Notice that's 3 clusterings all close together that the SPC has already identified: Monday, Tuesday, and Wednesday. From here, let's quickly talk about 1 o'clock in the afternoon when the model's valid on Monday. Remember, the low is here. There's a large cloud shield out ahead of it. Now, remember, my coloring here really makes it look like it's constant cloud cover, but we know that that eclipse is going to roll through right about there, right? I think we're going to have some mid-south viewing, maybe to southern Illinois and Ohio Valley, getting up toward the Great Lakes. Honestly, I mean, if I wanted a guarantee on this, I think I'd have to go pretty far into the northeast for cloud. But this, I don't want anyone to look at this and assume that everywhere that it's white, it's going to be no viewing at all. But this is the unfortunate case of having one of these in spring when we got troughs rolling across the country. So I wanted to give you an update on the cloud cover there from the European model. But if we take what we just saw in the multi-model analysis and say, what does it look like in terms of precipitation compared to average? There's the next 7 days. So this is drier than average in the European, wetter than average in the European. And here's the GFS. Overall, there are decent similarities to this. The GFS, though, does have much heavier rain in pockets down here that the European model does not have. So snow on this, well, still more coming into the Rockies, summit of the Sierra Nevada, and we're still watching one system leave here. Let's get on then to week 2. I'm pretty excited about this. I worked yesterday on some new maps for you. So I'm going to now start processing the entire European ensemble. So my map's going to change a little bit in their shape and view because I think this is a better view of it. But here's day 8 through 14. That's the 12th through the 18th. There's that open planting window we've been discussing. Here it is in the GFS. And here it is in the European ensemble probability, or excuse me, not probability, but precipitation anomalies. So multiple models showing up with the same pattern once we get out there past the 12th. All right. So are the temperatures going to cooperate? Well, we know there's a lot of cold air this morning here, frost and freeze warnings. But over the next 7 days, watch this. We're almost done with this video. There's that warm up on the south winds. Here we go. Saturday moves east. Sunday, that's when the low is sitting and spinning here, remember? Getting into Monday, this is where the first round of severe weather will be to the south, much warmer across the Ohio Valley, Mississippi Valley. There's Tuesday, the system's spreading its rain farther to the south, but take a look. Much more mild air by next Monday, Tuesday, Wednesday, not just for the Midwest where I've been focusing, but look at the West. And this is just cloud cover induced in rain. Day 5 through 10. Day 10 through 15. And it's also in the European model. That's day 5 through 10, day 10 through 15. So it is going to look like an early open window for a lot of spring planting. It's going to be coming in through soon. And I don't have any reason to tell you that the models are suggesting that the end of April goes back cold. I think this is a snow feedback issue. And you notice right here in the midsection of the country, overall mild and no real strong indications that through early May, we're going to knock temperatures way back anywhere, even though you're like, well, I see cooler here. Well, got to temper that a little bit. I'm not so sure how cold it's going to be. And just so you know, let's take you back there to that kind of finish to April. The GFS extended is on board as well. Now, what about precipitation? Okay, some models have gone over drier for more open planting windows in this area. Most of this, though, is a result of that drier week 2 forecast. When this is the 30-day map, so of course week 2 is in it. I think we do close up some of those windows in late April and early May with normal spring precipitation. But this is the GFS representation of that time frame, and here's the European. There's at least some agreement. But I think a lot of this is just persistence bias in the model. With all of that, I've got one more thing to share with you, and that is that my narrative for South America has not changed. In fact, the models even went wetter for most of the Safrinha crop. I was talking to several of my colleagues yesterday about the drought issues that have hit parts of like Mato Grosso do Sul over toward Paraná. This is about, I was told, about 30% of the total production down here. And these rains would be critical to the success of the Safrinha crop. So overall, I had a forecast, which I gave you many times, that I thought this would be drier by now, and it is not. That is a major bust. I just want to bring you up to speed on it. Hey, thanks for a great week. You have a good weekend. I'll talk to you next Monday. Thanks.